All right. Final two examples. Number 5. Again, some of you, I'm certain, will look at this and maybe take the route they think is best to simplify this. And the route you take may be different than the route I take. And that is 100% okay. There's nothing wrong with that. Again, as long as you're following the properties of exponents, basic properties of algebra, order of operations, things like that, it doesn't matter. All right. So I'm just showing you like one route to take. Again, as per usual, guys, if you have any questions, concerns, please don't hesitate to reach out and to me and ask. All right. It's important you do that. All right. Number 5. Let's go ahead and start this thing. I'm going to stop talking. Let's get to work. Okay, so I'm going to go ahead and, I'm recognizing you have exponents occurring on top and on the bottom, and, you have a division operation occurring. So you really have to handle the exponents first on top and on the bottom. You can't divide first because exponents occur before the operation of division. All right? So if you wanted to, you could, distribute this -3, multiply it through every exponent on top. Same with the -2. You can multiply it through every exponent on the bottom. I'm not going to do that. I'm going to go ahead and do this first. See if you can figure out what I'm doing. Do you already know what I'm doing? I hope so. What am I doing? That is the question. So what did I just do? I just inverted both of those bases. That's what I did. This -3 allowed me to do what with this entire base? It allowed me to move it from the numerator into the denominator, and now it's raised to a +3. And I did the same thing with this numerator. Now this denominator, now in the numerator. Okay. So now what am I going to do? Well, let's go ahead and try this. Let's go ahead and understand this is 2 to the first. This is 3 to the first. And now let's go ahead and apply that product to a power property. Okay, and we've done this before. So again, what you're really doing is multiplying every single exponent inside the parentheses by the exponent outside the parentheses. So on top, you get what? You get 2 squared, x to the 6th, and then y to the -4. Okay? Multiplication. In the denominator, you get 3, what? 3 cubed, x to the -3, and then what's 3 times 3? 9. That's correct. Y to the 9th. All right. Are we finished? Nope. So let's rock and roll. Let's keep going here. Let's finish this thing. 2 squared's 4. 3 cubes, what? 27. Go ahead and knock out the numerical coefficients first. And now let's review how I handle division of like bases. So I'm dividing right here, right? X to the 6th divided by x to the -3. My like base is an x. Okay, so which exponent is greater with respect to base x? Is it a 6 or a -3? It is a 6. That means that this x base will remain in the numerator. Now, the second question is, how much greater is 6 than -3? It's 9 greater, so x to the 9th. Final. Okay, let's look at the base y. All right, well, which exponent is greater with respect to the y base? Is it 9 or -4? 9, of course, is greater than -4. That means that y will stay in the denominator. Okay, next question. How much greater is 9 when compared to -4? How much greater is 9 than -4? It's 13 greater. So that's how I do it. We are now finished with number 5. All right, number 6. So this is a kind of a different type of situation, but it still involves not only the properties of exponents, but the information we looked at in section 1.4 as well. The concept I'm referring to is LCD. Okay, so what I would do first in this situation is apply the definition of a negative exponent to a base. All right, any base to the negative 1 is the same as that base, excuse me, 1 over that base. So here's what I'm saying. I'm saying x to the negative 1 is 1 over x. Y to the negative 1 is 1 over y. X to the negative 1 is still 1 over x. Y to the negative 1 is still 1 over y. Now, do you remember how we handled it at this point, looking back at section 1.4? We came up with an LCD. So the LCD here is going to be the product of what? YX. Or XY, whatever. It's commutative. Okay, so what we have to do is we have to, in essence, distribute this XY through every one of these 4 parts. All right. And again, understand this really means, guys, XY over 1 divided by XY over 1. That's what it really means. I'm telling you that so you remember that this is in the numerator. So what's 1 over x times xy? 1 over x times xy. Think about that. 1 over x times xy. That's just y. Okay? Here's what I'm saying. 1 over x times xy. The x's cancel. The x's cancel. And you just get y. Okay? Again, if you have questions or concerns, please reach out to me. That's what I'm here for. All right, what's 1 over y times xy? Y is canceled and you get plus x. All right. Moving to the denominator, what's 1 over x times xy? What's xy times 1 over x? The x's cancel and you get y. What about this one? Minus 1 over y times xy. What's xy times a negative 1 over y? Y is canceled, you get minus x. And you're finished. You're finished with example number 6. And we're also finished with the notes from section 1.5. Hope you're doing well.